Hey guys, I just realized I started the video without my calculator. Alright, you can't do math basically without a calculator. Alright, so we're going to start this chapter. It's about probability. Um, and so it starts off kind of simple and you're like, I got this, and then it gets kind of difficult. So just hang on tight. We're going to get through this together. Okay, so probability experiment is you just actually doing it. You flipping a coin, you rolling a dice, you drawing a card out of a deck. The outcome is, there's 75% chance of rain, or you have a red marble, a blue marble, purple marble, and yellow marble in a jar. What's the probability of getting the yellow marble? It's just of a single trial. Okay. The sample space is all the possible outcomes. And so we're going to learn how to draw and come up with those sample spaces. All right, so for example, here's one. We want the sample space for the gender. For the family has 3 kids. And so we want to see the sample spaces of all the different probabilities. And we're going to use B for boy, B for girl. All right, so you can have all girls. You could have all boys. Okay, you could have one girl, and then the boys could be after that girl. The girl could be sandwiched in the boys, but the boys could come first. Or you could have one boy instead of 2 boys, and you could have the boy at the beginning, you can have the boy sandwiched, or you can have the boy at the end. And so these are your probabilities. This is your sample space for having 3 kids. This is all girls. This is all boys. This is 1 girl, 2 boys. This is 1 boy, 2 girls. So there are 1, 2, 3, 4, 5, 6, 7, 8 possibilities. All right, we'll do this one. A family special neighborhood restaurant. So we're at Luby's. Okay. My favorite ever. Whoa. All right. And so they have 2 appetizers available. Appetizer 1, appetizer 2. Then they have 4 entrees. Hang on. Uh-oh. Hang on. All right. Then they have 4 entrees. Entree 1, entree 2, 4. 1, 2, 3, 4. And then they have 3 desserts. So then you could go 1, 2, 3. Dessert 1, dessert 2. 3, 3. I'm not writing that D over again. But that's dessert 1, dessert 2, dessert 3, 3, and then this one. All right. Do a tree diagram, which is what we have just done, to figure out how many possible dinner combinations there are. All right, well, you could do, appetizer 1, entree 1, dessert 1. You could do dessert 3, entree 3, appetizer 1. So all these guys right here are different possibilities. And so there are 4. There's 8 here. Hang on. That's not correct. 6, 12. Sorry, I can't count. There are 12 there, and there are 12 here. So we have 24 possible combinations. For example, you could do like dessert 2, entree 2, appetizer 2. Okay, so that's a tree diagram. Later, we're going to learn In another part, we'll learn that really you just have to take these numbers and multiply. So 2 times 4 times 3 is still 24. All right, event is the set of outcomes. A simple event has got one outcome. A compound event, totally want you to learn how to read typo. I'm pretty good at it, actually making typos. Just something for you to add on your resume. I can read typos. I crack myself up, and that's really all that matters. Okay, compound event, something with more than one outcome. So you roll a die and you pick a card, or you get an appetizer and a entree. And then equally likely events are things that are the same. So, you know, you have a 50% chance on a on a coin to get a tail, and maybe the rain is 50% today. So those are equally likely. Totally unrelated, but equally likely. All right, so classical probability, it assumes everything's equally likely, and we do sample spaces, and then we probability. Empirical probability, you actually like do the experiment, or like a study has been done to figure out, you know, the types of transportation people do, or the favorite types of food different people have. And then there's subjective, which is opinions, and you kind of do estimations. Just want you to let you know that there's 3 kinds. All right, classical probability, just probability you're used to. All right. So probability, PE, that's P of E. That means the probability of the event. Really what you're just doing is you're trying to find what you want out of total. It's really all you're doing for probability. I want to figure out how many even numbers are on a 6-sided die. Gosh, excuse me. And so a couple of things. In this class, we're going to do a reduced fraction or decimal place. The rounding is going to vary. In mainstream like society, they use percentages because percentages because people find decimals and fractions confusing. Okay, so I will be pretty clear about kind of what I want. Normally it is a decimal or a fraction, unless like you see the words, hey, I want this as a percent or something. All right, if you have no clue about a deck of cards, it's going to be confusing because a lot of the problems we're going to do involves a deck of cards. So here's what a deck of cards looks like. Notice that every number, there's 4 of them. Okay, there are 4 suits. Okay, there's clubs, spades, hearts, diamonds. Then there are face cards. The face cards are Jack, Queen, King. I'm going to consider the ace like the value for the number 1, and not a face card. Sorry. Notice there are 13 in each suit. Also notice there's 2 colors, red and black, and there are 26 red, 26 black. These are okay. And so if you're not used to a deck of cards, maybe just have this information just side as you do problems. Because I don't want it to be, oh, I have no idea about a deck of cards, and so you get the probability wrong, when you could just have this as reference when you're doing the probability. And that link right there, it's not super long if you need any more information. All right, we want the probability of getting a red face card, so Jack, Queen, King, when it's randomly drawn from an ordinary deck of cards. I am so sorry. All right, and so this time I told you all three. So a face card is Jack, Queen, King, and then there's 3 face cards per suit, and there are 2 suits that are red. So we have hearts and diamond, and there are 3 in the hearts and 3 in the diamond. We have 6. We want red face card. There's 6 of them. We have the 1 over the total. There are 52 cards. And so if we reduce this, we can divide 6 and 52 by 2, and we get 3 over 26. So that's the fraction. If we change it to a decimal, 3 divided by 26, we get 0.12 rounded. So that's the decimal, and then the percent would be 12%. That's a percent. It's ugly, but it's a percent. Okay, so family has 3 children. You want the probability of exactly 2 are girls. So remember we had all boys, girls, then you put the girl with the boy. Notice my kind of go-to is do the girl on the diagonal, and then I do the boy on the diagonal. All right, and then we want 2 of the 3 are girls. So this is 2 girls right there. There's 8 total, and there's 3 chances to have 2 girls. So that's your answer. Okay, 3, 5 if you wanted the decimal. And then if you wanted a percent, it'd be 37.5%. I'm going to stop this video and I'm going to start the next video right here.